Alyssa is cracking an egg and separating the yolk from the egg white because we only want to use the egg white. Look at her as she does it so precisely. Great job. Now we want to make sure that the egg white is 12 centimeters at least in diameter.
And it is!
Now place it in the microwave.
We will now cook it for around 25 seconds. As you can hear the popping, that is the egg cooking.
The traditional microwave would spin in a clockwise direction to even the heat. But since it stays in one place, certain spots heat up faster than others.
Next, Alyssa will measure from the middle of each part of the cooked egg to the other middle. And what did you get, Alyssa?
4.3 centimeters.
4.3 centimeters.
Now we're measuring the distance from the hot spot of the circles in the egg to the other hot spot.
I got about a distance of 5.2 centimeters.
And now the edge-to-edge measurement.
I got that around 7.8.
Take 3 as Alyssa measures the center-to-center distance of the hot spots of the egg.
This one's like 5.1.
In the edge-to-edge measurements for the upper and lower mounds.
7.2.
We were looking to find the speed of light in the microwave, and to do this, we had to find the wavelengths in the microwaves. With this, we would find the hotspot distance times 2 to find the wavelength. The hotspot distances for each of the trials are listed here, so we multiplied those by 2 to find the wavelength. And as you know, frequency times wavelength equals velocity. We found that the frequency in the microwave was 2.45 times 10 to the 9th hertz, and we multiplied that by all the wavelengths we found. And here are the values we found for each trial, which are relatively close to the actual speed of light down here.